All right, so what I want to do now is I want to do a little bit more of this two-column proof, because I know those are giving you some problems. So I want to go through some of those examples. So there's 3 that I want to do today. So the first one, this actually comes from your textbook. This is on page 30, and this is exercise 12. So it says the space shuttle landed in California, excuse me, the space shuttle landed in Florida, or it landed in California. If the space shuttle landed in California, then the alternate landing schedule was used. God bless you. But, God bless you, the alternate landing schedule was not used. Therefore, the space shuttle landed in Florida. And it's not essential that you copy this. This actually just shows up straight in your textbook. This is on page 30 in your textbook. So if you want to follow along there, that's fine. Or you can make sure it's in your notes. The space shuttle landed in Florida, or it landed in California. If the space shuttle landed in California, then the alternate landing schedule was used. But the alternate landing schedule was not used. Therefore, the space shuttle landed in Florida. So I want to list my premises and list my conclusions, and I do this sentence by sentence. So the first sentence says the space shuttle landed in Florida, or it landed in California. So what type of statement is that? That'd be a disjunction. You know it's a disjunction because you see that word or. So the space shuttle landed in Florida, or it landed in California. So what letter would you like for the first part of that sentence? The space shuttle landed in Florida. F? That's our conclusion.
F.
The space shuttle landed in Florida. That's F. So why is it important to list all of these premises and list the conclusions? Why is that important? Yeah, the thing is, this is, what, 5 lines, 6 lines? It's, almost 100 words. This is much easier to deal with. The symbols are going to be much simpler to look at. It's going to be easier for us to recognize modus ponens, modus tollens, hypothetical syllogism. It's going to be easier. What's also nice is this conclusion, this is my target. That's what I'm trying to reach. I'm trying to get to this point. So, in our two-column proof, we have statements and we have reasons. In our statements, we put all of the things that we know are true. And in our reasons, we put why we know that they're true. So the first statement I have is F, disjunction, C. Why is it true? It's a premise. Okay? We're kind of assuming that these premises are true, and then we're working from that. What's our second premise?
C, conjunction.
C, conditional A. And why do we know it's true? Because it's a premise. And what's our third premise? Negation A. And why do we know it's true? It's a premise. So this is always our first step in doing a two-column proof, is to list all of our premises. Now, we also remarked upon something last Thursday. We noticed that modus ponens, modus tollens, hypothetical syllogism, they all start with what in parentheses?
A condition.
A conditional. So the thing is, I want to make sure that everything is either a conditional or a separate letter by itself. So I'll have a conditional and its antecedent, or a conditional and the negation of the consequent, or a conditional and a conditional. That's modus ponens, modus tollens, hypothetical syllogism. Statement 1 is a disjunction. It's not a conditional. It's not a letter by itself. So we talked about this on Thursday. We said whenever we see a disjunction, is there a way to change a disjunction to a conditional?
Yes.
What's that process called? Denying the antecedent. So what I'm going to do is I'm going to do denying the antecedent on step 1. I'm going to use up step 1 and I'm going to change it to a conditional. If I'm denying the antecedent changes to what? Negation F. Condition. That is my statement 4. Notice I've used up statement 1. And now it's time to play the matching game. Keep in mind that when we put stuff together using a conjunction, we're doing so with matches in mind. And I have 2 things that match right now. I notice that this C and this C match. I also notice that this A and this A match. So I have 2 possible things that I could put together. I could put together statements 2 and 4 in some order, or I could put together statements 2 and 3 in some order. So my question to you is, what do you want to do right now? 2 and 4? Okay. So if I'm going to put 2 and 4 together, which one do I need first? I need the F conditional C first. So I'm going to write it here, and you'll see why we're choosing this one to be first. So this is the conjunction of 4 and 2. So why did I choose to put 4 first?
Because if you put negation F conditional C, you got matches with C.
Mm-hmm. Remember that my hypothetical syllogism said P conditional Q and Q conditional R. Those middle letters, the Q's, have to match. If I put number 2 first and I put number 4 last, then the outer parts match. And that's not hypothetical syllogism. I want the inner parts to match. So when I do this, when I use hypothetical syllogism to reduce this, so hypothetical syllogism on statement 5, these parts are going to go away. And I'm going to be left with my first antecedent, negation F. And I'm going to be left with my last consequent, which is A. So what I end up with is negation F, conditional A. Now, by the way, I've forgotten to mark some things. We used up statements 4 and 2. And we used up statement 5. So we've washed our hair 1 time. So we've lathered, we've rinsed. Is that our conclusion?
No.
So what do we need to do?
Repeat.
We need to repeat. At this point, what are the only statements left that I haven't used? 3 and 6. Which one would come first if we were to put those together?
6.
Why?
Because
it has the conditional. Remember that in modus ponens, P conditional Q comes first. In modus tollens, P. A second one of these. This is not in the textbook. This is one that I made up, so you'll have to copy it down. Barney likes to bowl, and Wilma has red hair. If Barney likes to bowl, he will go bowling. If Barney goes bowling, then he will take Fred with him. Therefore, Barney took Fred bowling with him. Okay, so let me repeat what we've got here. Barney likes to bowl, and Wilma has red hair. If Barney likes to bowl, he will go bowling. If Barney goes bowling, then he will take Fred with him. Therefore, Barney took Fred bowling with him. So let's talk about how we would write these premises. Tell me about the first sentence. Disjunction?
Conjunction.
Conjunction.
Oh.
How do you know it's a conjunction?
Because it says and.
Because it says and. So my first premise is an and. So give me a letter for the first part. Barney likes to bowl.
B.
B, okay? Give me a letter for the second part. Wilma has red hair.
R.
R. So Barney likes to bowl and Wilma has red hair. Period. Second sentence. Premise 2. If Barney likes to bowl, if. Conditional.
B.
B is my antecedent. If Barney likes to bowl, he will go bowling.
O.
G, go, yeah, G. If Barney goes bowling,
B.
No.
well, no, B is Barney likes to bowl.
G.
G. And this is an if, so it's a
Conditional.
conditional. Then what?
F.
F, he'll take Fred bowling with him. Therefore,
There's conclusion.
that's our conclusion. Therefore, Barney took Fred bowling with him.
F.
F. So any questions how we wrote this symbolically? So what do we do?
2
Two-column proof. Statements and reasons. So tell me, what do you know is true? Premise 1. B conjunction R, and why is it true? It's a premise. Tell me about my second statement that I know is true. B conditional G, and it's a premise as well. Third statement that we know is true. G conditional F, and we know it's true because
Because it's a premise.
it's a premise. All right, so any questions so far? All right, now I'm looking at this first sentence that says, Barney likes to bowl and Wilma has red hair, and then we never talk about Wilma again. R represents Wilma has red hair, and I never use R in any other statement. And what we talked about on Thursday is we said whenever we have a conjunction, we can take only the stuff we want and we can get rid of the unnecessary information. We're probably going to get rid of R. And do y'all remember what that theorem was that we talked about?
Theorem 8A.
That was Theorem 8A. So I'm going to use Theorem 8A on Statement 1. It's going to use up Statement 1, and I want just the stuff that I need. What's the only thing that I need from that statement? B. Okay. So, real quick recap. Modus ponens has P conditional Q. Modus tollens has P conditional Q. Hypothetical syllogism has P conditional Q. I want conditionals and I want single statements. I don't really want compound statements like this. So we have tools to get rid of them. We have tools to get rid of disjunction. That's denying the antecedent like we just used. We have tools to get rid of conjunctions. We have Theorem 8A, which breaks it apart. Notice that all I have is what I want, B. So now I'm ready to put stuff together. And I have two options of what I can put together. What can I put together? I can put 2 and 3 together. 2 and 3 together because they share the letter G. What else could I put together?
You can put 2 and 4.
I could put 2 and 4 together because they share a B. Remember, the idea here is we're looking for matching letters. We're looking for pairs. Yeah.
When it says 4, it says theorem. What is that?
Theorem 8A on, and then I've got 1 with the circle around it. And the Theorem 8A, that was one of the things we learned on page 23. We saw that whenever we have P conjunction Q, that implies P. That was the Theorem 8A that we talked about last week. Remember when we talked about modus ponens, modus tollens, hypothetical syllogism? Theorem 8A is kind of the one that we ignored. But I said it was important, and don't forget it, and this is why. All right, so do y'all want to put 2 and 3 together or 2 and 4 together?
2 and 4.
2 and 4? Okay. Which one would come first? Why?
Because it always starts with the conditional.
All of the arguments that we learned, modus ponens, modus tollens, hypothetical syllogism, all start with the conditional. So I want to put the conditional first. This is the conjunction of 2 and 4. So we're going to have B conditional G and B. And now I need to recognize this. Is this modus ponens or is this modus tollens? This is modus ponens. How do you recognize this as modus ponens?
It doesn't have a negation.
We're not doing the negation of our antecedent. We're not doing the negation of our consequent. It's just antecedent, consequent, antecedent. So modus ponens on statement 6 means that we're going to have what? Excuse me, on statement 5. What is modus ponens going to give us? I've got B conditional G and B. It's just going to give us G. Now, by the way, we've used up statements 2, we've used up statement 4, we used up statement 5. Is G our conclusion?
No.
No. What is our conclusion? F is our conclusion. That's what we want to reach. So I've lathered, I've rinsed, I need to repeat. What statements do you want to put together?
3 and 6.
Yeah, 3 and 6 are the only things we haven't used so far. We need to put 3 and 6 together. Which one comes first?
3 because of conditional.
3 because it's a conditional. So G conditional F and G. That's the conjunction of 3 and 6. Modus ponens, modus tollens, or hypothetical syllogism. Modus ponens. Why is it? They gave us the antecedent, so we need the consequent. So this is going to be F. That's our conclusion, isn't it?
Yes.
So this is a valid argument. My goodness, I forgot to write valid up here too. I'm a horrible teacher. So sorry. All right, so at the end of class on Thursday, we talked about how we used denying the antecedent or Theorem 8A to take care of disjunctions or conjunctions. So any questions on those before we do our last example of a two-column proof? All right, our last example of a two-column proof. Oh my goodness, right? Number 41. Everyone's favorite problem, right? So, if I'm going to do a two-column proof, I need to start off with statements and reasons. So what's my first statement?
P disjunction Q conditional.
Right? And that is a premise. What's our second statement?
R conditional.
R conditional
S
S disjunction T, and it is also a premise. What's our third statement?
T conditional W.
T conditional W, and it is also a premise. And our fourth statement?
It's negation S.
Negation S, conjunction,
Negation W.
negation W, and it's a premise. And by the way, just I want to do a quick reminder on here. Our conclusion, what we're trying to get is negation P and negation Q. So let me talk about why this is hard. And in order to talk about why this is hard, I actually need to take a look at a former homework problem. I want to take a look at problem 34. So we had this sentence. If a whale is a mammal and a spider has 6 legs, then a frog is a reptile. And this is hard because there's 3 different things going on here. We've got a whale as a mammal. We've got a spider has 6 legs. We've got a frog as a reptile. That's what made this problem confusing. But I know that I have an if and I have a then. So I know that I've got a conditional. And I've got frog as a reptile, that's are. So if this was a language arts class, I would say that this is a compound sentence, right? I've got sentences put together with ands and ors. I can put those things together to make sentences longer. What made this problem difficult, what made so many people have problems on number 34 is the fact that it's a compound sentence. And that's what's happening on number 41 as well. Notice that I've got P disjunction Q, and I've got S disjunction T. And why they're hard is because it's compound statements. But sentence 1 is a conditional, and sentence 2 is a conditional, and sentence 3 is a conditional, and sentence 4 is a conjunction. Now, we just talked about conjunctions. We said for conjunctions, what can I do to break them apart?
Theorem 8A.
Theorem 8A. So what I'm going to do is I'm going to break apart statement 4 by saying theorem 8A on line 4. And so I can break off the first part of it. But I want to mention something here. In our previous example, we left Wilma alone because Wilma was never mentioned again. Is W mentioned anywhere else?
Yes.
Yeah, it's on statement 3. It'd be really nice to put negation W with statement 3. That's a real good modus tollens. So I'm actually going to break off both pieces because I can use both pieces. So this is theorem 8A on statement 4 again. So I want to talk about this because this is probably the trickiest part, and it's right at the beginning. Yes, in mathematics we have problems where we have extra information. The question is, do you know right off the bat that it's extra information? Sometimes you don't. Sometimes you do, but sometimes you don't. Do you want to just cross off extra information, or do you want to wait until you figure out, you know what, I really don't need this information? Raven, can you put that away, please? Just put it on the chair. That way it's not on your desk. So because I don't know that negation W is extra information yet, maybe it will be, maybe it won't be, I'm going to save it. So I've got statement 6. If I ever need to, I've got statement 6 that I can put it at. By the way, we've used up statement 4, and theorem 8A is the only thing that we have, the only reason that can use a statement twice. So now we're playing the matching game. I need to match up letters. Do you see any letters that match? 4 and 6, I noticed, well, but we used up 4, so 4 is not really an option. 3 and 6, they both have W's, don't they? Is there anything else? 2 and 1, they both have R's. Remember that we're playing the matching game. We're looking for letters that match.
5 and 2. 2 and 3. 5 and 2.
5 and 2 both have an S. The problem is this S is part of a compound, so I'm not ready to deal with that yet. So let's take a look at the 3 and the 6. Let's put 3 and 6 together. By the way, which one would come first? 3. So I'm going to have T conditional W and negation W. So that's the conjunction of 3 and 6. And by the way, that used up step 3, that used up step 6. So I get T conditional W and negation W. Is that modus ponens or modus tollens or hypothetical syllogism?
Modus tollens.
That looks like tollens, right? So I've got W, and then I've got negated W. So I should just end up with negated T. That's modus tollens on statement 7. And by the way, that used up statement 7. So I've got negated T. I can also put statements 1 and 2 together, correct? Do you want to put 1 first or 2 first?
2.
You want 2 to go first? If I do 2 first, I'm going to have R conditional the compound statement and this different compound statement conditional R. Yeah, I really want those middle letters to match, don't I? So what I'm going to do here on statement 9 is I want to do P disjunction Q conditional R and R conditional S disjunction T. So I want to do the conjunction of 1 and 2. By the way, that used up statements 1 and 2. Is that modus ponens or modus tollens or hypothetical syllogism?
Hypothetical.
How do you know it's hypothetical syllogism? The 2 middle letters are the same, and we've got 2 conditionals, right? So hypothetical syllogism on statement 9 means that we're going to have our first antecedent, P disjunction Q, conditional, our second consequent, S disjunction T. And by the way, that uses up step 9. Now, at this point, I have statement 5, I have statement 8, and I have only statements I have left. Statement 10 deals with compound sentences, a compound statement. Statements 5 and 8 aren't compound, they're the single letters. Do we have a way to put statements together? What allows us to put any 2 statements together? How do we start washing our hair? Well, before we rinse, we lather, right? We have to mix together the soap and the water. And we do that by taking the conjunction of 2 statements. Can I put 2 statements together using a conjunction? That's step 2, isn't it? So let's see, which ones do I want to put together?
10 and...
Well, I see S with T together, right? So I really want to have 5 and 8 together. I really want that negation S and that negation T together. So let's do the conjunction of 5 and 8. That's going to give us negation S, conjunction, negation T. And that used up 5 and 8. Gosh, that was so close. I mean, we got the S and the T together. We got the S and the T together, just like we have here. The problem is this is a conjunction and this is a disjunction. And there's no way that we can take a conjunction and change it to a disjunction, is there? No law would help us, right? Well, yeah, didn't De Morgan's law say the opposite of a conjunction is a disjunction? Notice that I've got negations here. So if I was to start off with some type of disjunction, it would be S disjunction T, but with the negation out in front. That's De Morgan's law. De Morgan's law on step 11, and that's going to use up step 11. So the only thing I have left is step 10 and step 12. Step 10 has a P disjunction Q conditional S disjunction T. And here I've got negation of S disjunction T. This is the opposite of the consequent. My goodness, let's put these together. Let's see what we got. We've got P disjunction Q conditional S disjunction T and negation parentheses S disjunction T. So that's the conjunction I've got a conditional, and I've got the opposite of my consequent. Is that one of our rules? No? If I have a conditional, and then the opposite of a consequent, I've got to match here. This S disjunction T matches the S disjunction T. They're just opposites of each other. So we didn't have a rule that said if we have P conditional Q and negation Q, that isn't one of our modus something or other.
Oh, it's not.
That's modus tollens, isn't it? But because it's a compound, I have to look at the opposite of the whole thing, the opposite of the parentheses. So modus what?
Tollens.
Modus tollens on step 13 is going to give me the negation of P or Q.
Is that a negation?
Yeah, there was a negation here because there was a negation here. And that used up steps 12 and 13. So everything's used up except for 14. Is this my conclusion? No?
Yes.
Remember, our conclusion was up here.
Yes, that's your. Oh.
No, yes, yes, no, maybe so. Other De Morgans? What's the opposite of a disjunction? Conjunction, okay. What's the opposite of P?
Negation P.
Negation P. What's the opposite of Q?
Negation Q.
Negation Q, and that is De Morgan's law. Yay! It works! It's valid! Hooray! Hip hip. Hooray! I did problem 41 on your homework for you. Hip hip.
Hooray! That's awesome.
Okay, well, if you already have it, then we'll just move on. All right, going on to today's lesson. So the first thing I want to talk, yes. First thing I want to talk about is predicate logic. So I'm going to write some sentences up here. And I want you to notice something about these sentences. So I'm going to tell you that Garfield is a cat. And I'm going to tell you that Fluffy is a cat. Fluffy is a cat. And I'm going to tell you that Mr. Whiskers. So I've got Garfield is a cat. I've got Fluffy is a cat. I've got Mr. Whiskers is a cat. What do these sentences have in common? Is a cat. What's different is the subject. Who we're talking about in each of these sentences is different, but they all have the same predicate. The predicate part is a cat. And so what I can do is I can use a single capital letter to represent is a cat. So in this first sentence, who is a cat?
Garfield.
Garfield is a cat. I would say see Garfield. The subject of my sentence is Garfield. Garfield is a cat. In the second sentence, who is a cat?
Fluffy.
Fluffy is a cat. So see Fluffy. In the third sentence, who is a cat?
The Whiskers.
Mr. Whiskers. So see Mr. Whiskers. So in other words, this C represents is a cat, and I can talk about all the different subjects that are cats. I can even talk about X is a cat, because sometimes we have a situation where I don't know the name of the cat. So I just use X to represent it. Who is a cat? X is a cat. Fido is not a cat. This has got to have negations in it, yeah. So it's going to be negation C for is not a cat. Who's not a cat? Fido. Snoopy is not a cat.
Snoopy.
Negation C, Snoopy. So I can talk about this predicate logic to represent a sentence that all have the same predicate, no matter what the subject happens to be. Who am I talking about? Well, I may be talking about Garfield or Fluffy or Mr. Whiskers or Fido or Snoopy or some unknown X. You ever notice how in your math classes we use a letter to represent an unknown, like X might be a variable we'd solve for?
Yeah.
So that idea. So let's try another set of sentences like this. 3 is a whole number. Okay? So we're using the predicate is a whole number. We can use W to represent that. But what's the subject of the sentence? 3. We're talking about 3. Who is a whole number? 3 is a whole number. Zero is a whole number. That would be W0. So in other words, if I give you a sentence, could you give me the predicate notation?
Yes.
If I gave you the predicate notation and told you W573, could you tell me what the sentence would look like? What would that sentence look like? 573 is a whole number. So in other words, I should be able to work backwards and forwards. What if I told you that 0.4 is not a whole number? That'd be negation W, 0.4. What about pi is not a whole number? That'd be negation W, pi. And similarly, if I was to give you negation W and give you 3/5, how would I write that as a sentence? 3/5 is not a whole number. How about WX? How would I write that as a sentence? X is a whole number. I could do negation WX. So we've got this notion of predicates. I can talk about a predicate, and I can use a single capital letter to represent a predicate. And the subject will always follow. Who's not a whole number? Well, 0.4 is not a whole number, or pi is not a whole number, or 3/5 is not a whole number, or x is not a whole number. Keep in mind that we're talking about capital letters. We said lowercase letters represent statements. Capital letters represent predicates. And this is why I made such a big deal a few weeks ago when I said you need to use lowercase letters when you're talking about statements. Because for us, capital letters will represent predicates. Make sense? So the last thing that I want to talk about quantified statements. Quantified statements. Now, when I talk about quantified statements, I'm talking about quantities. And for us, there are only two quantities. We have a universal quantity, and we have an existential quantity. So I want to talk about what these words mean. When I talk about a universal quantity, I'm talking about the universe. How big is the universe? No one knows. Huge, right? Gigantic, enormous, infinite. If I'm talking about a universe, then I'm talking about everything. So I'm going to use words like all, or every, or none, or no. When I talk about universal, I'm talking about everything or nothing, because I'm talking about the entire universe. When I talk about existential, though, what are the first 5 letters in existential? E-X-I-S-T, exist. So when I talk about existential, I'm talking about some, or I'm talking about not all. And so the difference is, am I talking about everything, or am I talking about at least one thing?
At least one thing.
Okay? This is at least one thing. So in other words, the difference between all dogs have fleas and some dogs have fleas. Okay? Some dogs have fleas would be my existential. All dogs have fleas is my universal. Now the symbol for a universal is an upside down A. That's the symbol that we're going to use when we talk about universals. The symbol for an existential, I can't do an upside down E because an upside down E is just an E. But we can do a backwards E. And so that's the symbol for an existential. So I want to talk about those 2 sentences we just mentioned. We mentioned all dogs have fleas. And we talked about some dogs have fleas. So let's see, if I was to say all dogs have fleas, how would I know if I'm telling the truth? Whenever I talk about a universal, I'm really saying if X is a dog, then X has fleas. So when I